I'm not able to go in very detail all the steps because I tried to limit this to 2 hours first and to point out the main point because you still have your design project to be completed. Steps in the design of beam. Okay. Now I'll go through the overall steps. This is what you will go through in your design project. Of course, you start with the key plan that you have decided. Then you go to estimate the beam section, which is your B and H. Okay. Then you determine cover. After that, you determine loading on beam. Okay. So after that, we can do design for flexure. Then we go for design for shear reinforcement. Yeah. After that, we go for deflection control checking. Then we do this detailing check, crack control, okay? Check for cracking. This is particular if necessary, okay? Then finally, we provide detailing drawing, okay? Detailing drawings where you make it clear what is the beam size to be used and how many of them, whether it is close to the top of the beam section or close to the bottom of the beam sections, and also some of the curtailment rules, because a bar does not have to provide, for example, those at the midspan is only requires at the location where the bending moment is maximum that we design for. As it goes toward the support, then number of bars can be reduced. So those are curtailments. Those are rules that we can follow. And class, these are process. This is a process in the design project that you go through. You start earlier on with architectural drawing, and you start on with the key, finally come up with the layout of the beams column, where you have slab, where you don't have slab. And so this we expected to see in your design project. Okay. But for test and exam, some of these informations already given. You do not have to go through because this will not be enough time for you to go through all of this. So this one, if already given, so please class use the data, okay? Use data given if it's already given, think in the test or in the exam, okay? No need, please do not redo unnecessary things, okay? So the next thing that I want to specifically talk a little bit more, I think spend a bit time, is this particular part. Okay. This can be time consuming if you are not sure about the process. If you're sure about the process, then at least you can go straight away and get the necessary design loading, which is in kilonewton per meter. But if you are not sure, a bit confused how you should get, then you are going to lose a lot of time here and you don't have time for the other parts. So let me try to give you the main idea behind determination of loading. Okay? The determination of loading use the data given to us. Okay? So specifically, this is about loading on beam. Now, the beam that we are talking about, it can be one of the span in the continuous beam. If we ask you to answer that, it can be one of the span in a continuous beam, or it can be simply supported beam, so only one span. Okay? But in your design project, you design for the whole continuous beam. If your continuous beam have 3 span, 4 span, you have to design for all the spans. Okay. Now, loading on beam, again, I stress, eventually it must be in kilonewton per meter. And loading of beam, why we determine this? It is because we used to calculate the ultimate design shear force and ultimate design bending moment. This one, to get this first, then we can only get the VED and MED for the design one. Okay. Then we have to pay attention. I think pay attention to the questions. Okay. Pay attention to the question how to get this. If the question is continuous beam, you cannot get VED and MED using formula for simply supported beam. It is not WL/2 for shear WL²/8. This is only for simply supported beam. Pay attention to the questions. Okay. Is the beam to be designed is simply supported? Is it a simply supported beam? Okay. Or is it part of a continuous beam? One span, part of a continuous US. Because if this is this or this, the way you calculate VED and MED, they are different. In the design project, you cannot just design part of a continuous beam. If your continuous beam has 3 span, 4 span, we have to design for the whole. Yeah, from span number 1, span number 2, span 3, and span 4, and then you have to design for the whole. Because continuous beam is a very time-consuming process to design. So if you ask the question asked to look at particular part, particular span of the continuous beam, then you only design for that span. Okay. So I'm going to give you an example of drawings where okay, if the drawing is given is something like this, this one I'm giving an overall overall view, not plan view. This is like, and you have a column here, this is a column, this is a column, beam, 1, 2, 3, 4, 5, 6, and there are more column here, and we give this name A, the grid line, A, B, C, and this one we have grid line 1, 2, 3, 4, 5, 6. So if given a drawing like this, then, for example, the particular beam to be designed, this, we have to get this information from the question. That's why in the beginning, I asked you, read the question. Yeah. Beam to be designed is span. This is span. This is span 2, 3 of maybe you can't see at the back there. Can you please tell me if you can't? I think there's already limit where you can see. Continuous beam B slash 1 to 6. So in your design project, if you choose this continuous beam, the interior for you to design, you have to design all span. You have no choice because you are in the design project. But in the question, say beam to be designed for span 2, 3 of the continuous beam means you only look at this particular span. Okay. And other things, what happened to other span, we do not require, and then so there's no need to spend time on trying to get bending moment and shear force in other span. Just consider in this span. So that is, if it asks span 2, 3 of continuous beam, B1 to 6. Okay. It can be span AB of continuous beam 6/A to C, then we design this span. Okay. So that is the things, okay? So pay attention to the questions, okay? Pay attention, spend some time at 1 minute in the beginning, read through the question and then understand what the question wants, and then just to try to avoid you answer unnecessary things. You write unnecessary thing which is not required by the questions. So it could be the question given, it could be, depends on the question given. It might be simply supported, okay? So if a question given is another one, again, we have so the question is asked to design beam to be designed, say 2/A to B, which means beam 2/A to B, this beam here. This is simply supported. This is a simply supported beam. So look at the questions. Which one is being specifically asked you to design? If the drawings given is like this, then ask you to design this, then this is simply supported. If ask you to design this particular span of this continuous beam, then it has to treat this as one of the span of the continuous beam, and corresponding calculations for VED, MED will be different. Now, Next thing, I'm going to talk a little bit more specific about loading now. Loading, we know that it is, you need to calculate the ultimate load, which is 1.35 GK and 1.5 QK. So loading on beam, we have two main parts. Now I take one example like this. Okay, this is part, this is another part continuous, I just break it there. And the slab here, I assume this as Lx, which is the shorter edge. And this is Ly. Okay. It can be the other way around, class. It can be the other way around. This is Ly, that is Lx. I'm take this particular case, this is Ly. Now, we are asked to design this particular beam, for example, this particular span of the continuous beam, this one. Okay, we are asked to design for this particular one. So let me highlight this one. So the loading that we have we have loading from the slab. And this loading from the slab, it must be converted to per meter run. It must be converted to per meter run on the beam, because the loading on the beam is always in kilonewton per meter. This is from the slab first, from the slab. You have loading from the slab, which is in kilonewton per meter square. And you have to calculate and get that effect of the slab load onto the beam in terms of kilonewton per meter. You're talking from the slab first. Beam supported slab. So slab load will go to the beam. The load from slab, you know, we have to the permanent one. And permanent, you have two types. One, it is dead load, which is self-weight. And the other one is the superimposed one. This is other than self-weight. Example, you have finishes. This is categorized under permanent, okay? And to get loading, we have to look at the slab, whether it is one way or two way. We have to look at the slab, whether it is one way or two way, okay? The same thing, we have variable from slab. This is depending on the usage. For residential, it has some range, and for office, so it is this data will be given to you if it is you are asked to design. So when you talk about self-weight, then remember class, self-weight, you must multiply with 25 kilonewton. You must multiply with 25 kilonewton per meter cube. Now to get the equivalent load onto the beam, we have to know whether the slab is one way or two ways. So if the questions does not state one way or two way, then you have to go through the process Ly or Lx. If it is more than 2, then it is one way. If less than equal to 2, then it is two-way. Okay. And whether it's one way or two-way affects the loading on the beam. Now I'm going to talk about the case of one-way slab first, to give you the idea how to convert this into kilonewton per meter square into kilonewton per meter run. Okay. Loading acting on slab is always given in kilonewton per meter square. So that cannot be used directly as the loading on the beam. You have to convert that, what is the equivalent effect in terms of kilonewton per meter run onto the beam. So let me start with the case of one-way slab. Okay? Let's start with the case of one-way slab. Okay. Now I have to take away this. I use example of this beam. If it is this beam here, then the same process, only thing is this beam carries slab from one side on it. This beam carries slab from both sides. So depending on the beam where the beam is, okay, is at the perimeter or is interior, or is there any slab? Sometimes the slab can be only one side only if this is a void. If there's a void here, then this beam carry only slab load from one side. Now it is one-way slab, then the loading that this beam has to carry from this slab and this slab will be half of this load here, and half of this load here will go to the beam. And the other half go to the other beam. Half means this one is Lx over 2. Half means this is Lx over 2. So now, how do we convert this into kilonewton per meter? So now, we first look at self-weight of slab, okay? Self-weight. So from this one, we have self-weight from slab, okay? Permanent, first one, self-weight of slab. This is equal to the thickness of slab in meter multiplied with unit weight of concrete, because this is a concrete slab, in kilonewton per meter cube. Self-weight of slab first. We haven't converted to kilonewton per meter, and at this stage, the unit become kilonewton per meter square. Okay. This is still kilonewton per meter square, but here, please note that we have to use unit weight of concrete. Here, 25. Here, unit thickness of slab, let's say 150 mm, convert that into meter, 0.15 multiplied with that, you get in kilonewton per meter square first. Okay. Then, when we convert, this is just self-weight of slab. Then load due to self-weight of slab on beam. Load due to self-weight of slab on beam. This one will be equal to whatever we'll get from here. And whatever you get from here, then you multiply with, you have one slab here, one slab here. I call this slab number 1, slab number 2. So you have Lx1 over 2. If this is slab number 1, then plus again the slab self-weight from the other side. If the thickness is different, then your self-weight will be different. Then multiply again with Lx2 over 2, which is here, the Lx of this and the Lx might be different. So this is, when we come to this stage, it is in kilonewton per meter. So that is from self-weight. So first, if you already know these steps, you don't need to go through this step directly, go through here, because to get to the beam, you need to go through these steps and then multiply with, if it is one way, half of this Lx over 2, plus if there's another slab here, half of the Lx here, and that gives you the total of the loading from due to self-weight of the slab onto the beam. And when it comes here, it is already in kilonewton per meter. Okay. Now, permanent has another component from slab which is other than self-weight. The one other than self-weight is like finishes, other than self-weight. We call it superimposed. They are permanent from slab. This is other than self-weight. Example, we have finishes. So this finishes load normally is given directly to you, 1 kilonewton per meter square or 1.5 kilonewton per meter square, already given directly in kilonewton per meter square. So this step is not needed anymore because it is already given. Finishes. Unless it is not given yet, you have to calculate. But if the question already given finishes, for example, finishes load is 1 kilonewton per meter square. So already given in 1 kilonewton per meter square. So in this case, load due to finishes on beam will be whatever load that we have here from finishes, multiply again Lx over 2 from one side, plus again, if there is finishes, another slab here. If the finishes here different, then look at what is the finishes. If they are the same, then the same thing. Multiply again with Lx over 2 from this side. That gives you the total load due to finishes on beam. And the unit is kilonewton per meter. So the permanent due to self-weight and other than self-weight is calculated in this way from the slab onto the beam. Okay. So we can, this permanent and this permanent, after you convert to kilonewton per meter and from self-weight, you can add them up. after you convert them into the similar kilonewton per meter, you can add them. But you cannot add kilonewton per meter square and kilonewton per meter. So that is completely wrong. You have to make sure you can add this permanent other than self-weight plus the self-weight one after you convert them in the same unit, kilonewton per meter. That gives you the total permanent load on the beam coming from the slab. Okay. So now variable load is treated in the same way. Variable load on slab will be treated in the same way. The load from slab has permanent and it also has variable. And variable is also directly given in terms of kilonewton per meter. This is directly given in terms of, this is in kilonewton per meter square, because this variable is acting on the slab. That's why it's in kilonewton per meter square. So in this case, load due to variable load from slab on beam is just equal to whatever variable here on this side multiplied with Lx over 2 plus, again, from this side, variable load, if this usage is different, if this is bedroom, if this is living room, maybe variable load is different. So you might get variable load different. Then multiply with Lx over 2 there. You add up, that gives you the total variable load on the beam in kilonewton per meter. So that is from the slab, settled. So you have variable one, you have the permanent one. Next, we go to load from due to beam itself. So load one online. Okay, can you see all the writing, class? Can you see all the writing, or you are doing your design project at the same time? Okay. Thank you. Thank you. Yeah. Load due to beam. Load due to beam has two parts. Okay. One which is self-weight. The other one is load directly on beam. Directly on beam, which is a brick wall. Okay. Wall. Okay. This general wall, it can be brick wall, it can be other kind of wall. So if the wall information is not given to you, it does not state whether the beam carries wall or not, you can ignore wall load. If it is specifically say that the beam carries a wall with a load of certain kilonewton per meter square, then you have to consider. So both these are permanent. Both these are permanent. These are both are permanent. These are permanent. Classified as a permanent load. Self-weight of beam. Okay. Self-weight on the beam. So we have a beam here. And you take 1 meter length, and this is B, this is H, Okay, that's the section of the beam. So self-weight of the beam, this one equal to B multiplied with H, then actually multiplied with 1. This is to convert to per meter. Then multiply with unit weight of concrete. 25. Okay, class, don't make mistake anymore. This is 25, not 35, not 30. Okay. So this is everything in meter, this is in meter, this is in kilonewton per meter cube. Okay, so we get, this is finally in kilonewton per meter. Loads on beam from wall, we have another load on beam from wall. If there is a wall. If there is no wall, then we don't have to consider. So load from beam from wall, we have to, if there is a wall here, if the beam carry a wall, carry wall load, okay? Then we have to know what is the height of this. What is the height of this wall? And we have to know what is the load of the wall. Okay? So this one, I take this load due to the wall. This normally we have to look for it in your design project. You have to look for it, or if the data is given, then use it. This is in kilonewton per meter square, and multiply with the height of the wall, and this gives us in kilonewton per meter. Okay. So all this is all these are permanent load, okay, in kilonewton per meter. Okay. So now, if I combine all this, then if I call this permanent load from slab, I call this WK from slab, okay, total one. I just give you symbol because in the actual calculation, you can go straight away, you get value. Variable load from slab, this is already in kilonewton per meter. And permanent load due to beam and wall, WKB, call that. This is also in kilonewton per meter. Okay. Then the design ultimate load, and this is ultimate 1.35 WK from slab plus WK from beam. Yeah? This must be in kilonewton per meter, then plus your 1.5 WK variable. So take note, this already convert in kilonewton per meter, kilonewton per meter, kilonewton per meter, then only you can add them up. You cannot add kilonewton per meter square with kilonewton per meter. That is understandable, logical. You cannot add kilonewton per meter square with kilonewton per meter. So make sure before you come to this stage for beam, whatever here is already converted to kilonewton per meter. Then only you multiply with this for the permanent one, and the partial factor of safety for loading 1.5 for the variable one. So this eventually in kilonewton per meter. Okay. In kilonewton per meter. So this is for one-way slab.